Hey FTC programmers! In this video we're walking through a complete teleop program written in Java for FTC. It features tank-style driving and even includes a servo-based plane launcher. Let's get programming! We start by defining our op mode. The class is called basic op mode and it uses the linear op mode base class. Notice the @teleop annotation at the top. That's what makes this show up on our driver station. Inside the class, we declare 3 hardware components, 2 DC motors for the drive system and 1 servo for the plane launcher. I did that right here. For my DC motor, I did a private DC motor, left DC motor equals null, and then for my servo, I did private servo plane launcher. And then I also put in a runtime right here to see how long my code will be running for. Now, in run op mode, we link the code to the get hardware configure on the robot controller using the hardware map.get. For this, you're going to go right into run op mode and you're going to write left drive equals hardware map dot get DC motor dot class, and then in these quotation marks you're going to put down whatever name you want to name your motor. In my case, I'm going to name mine left drive. And so when you go into your robot controller, it's going to look for your motors, and if you have it named left drive, right drive, or whatever you name your motor, that's what it's looking for right here. And now I'm going to do my right one. So what I'm going to do is I'm going to copy and paste what I did up above, and then I'm going to put right drive. And then for my servo, I'm going to do the same thing, but instead of importing the DC motor class, I'm going to import my servo class. So replace DC motor with servo. And then I'm going to replace the name. What I named mine was plane launcher for the servo, and then you're also going to put plane launcher here as well. Next, we set motor directions. Because most robots have mirrored motor setups, we usually reverse one side, so pushing forward drives the robot straight. For this, you're going to go below your hardware map, and I'm going to type left drive dot set directions dot reverse is what I'm going to do for my left side, which then means that my right side then is going to be forward, so that way then we have the robot driving the way we want it to. So change left to right drive, and then change reverse to forward. Now we wait for the start button, and then the loop begins. For this, you're going to go below your set directions, and you're going to type wait for start. And since I want to see how long my code is going to be running for, I'm going to do a run time dot reset. This is going to reset the amount of time that the code has been running for. In the main loop, we control the robot with POV drive, which combines forward and turning motion for smoother control. For this, you're going to go into your while op mode is active, and you're going to make a double drive equals gamepad 1 dot left stick Y, and then you're going to do another double turn equals gamepad 1 dot right stick X. And this right here is just calling on what gamepad stick you want to be using, and we're using gamepad 1 for this instance, so then I'm going to be using my left joystick to move forward and backwards, and then my right joystick X to have me a turn. Now for this, you actually need a minus sign in front of your drive, so that way then your robot gets positive values as you're pushing the joystick forward. And then we also need power for when you're pushing that joystick forward, so I'm going to do another double. and I'm going to put left power, and I'm going to do the same for my right power. And then below your joysticks, you're going to put left power equals range dot clip. Inside the clip, you're going to put drive plus turn, and then -1, another comma, and then 1. Now for this is setting your max and min of how much power you're going to actually put to that motor. And for this, you're also going to do the same thing for the rights, but instead of having a plus sign in between your turn and your drive, you're going to have a minus sign. So that way then you again have those reversed values. Now for the fun part, controlling the plane launcher with a servo. Pressing the A button sets the servo to 0.5 to launch, and B resets it back to 0. So for this, I'm going to go below my power and I'm going to do an if statement. If gamepad 1 A button is pressed, then the plane launcher, the servo, will then move to 0.5. I'm using this with a set position. We're going to do the same for the B button, but in this case we're going to have the servo move to 0, so it is back where it began. I'm going to do this for the A button. So if A button is pressed on gamepad 1, then the servo will then move to 0 as its position. We then send the calculated power values to the motors. So I'm going back to my drive, and right below my gamepad 1, I'm going to put left drive dot set power, and I'm going to do my left power for my left drive, and then you're going to do the same for your right drive. Change your left drive to right, and change your left power to your right power. And you don't need these extra parentheses right here. And again, as you're typing all this, make sure you're spelling all this right, so that way then it actually follows what you're doing. As you see right here, this is actually wrong. This should be your right power. And there we go, now it all works. Lastly, we use telemetry to send useful data like runtime, servo position, and motor power to the driver's station screen. For this, I'm going to go below where I set my drive's power, and I'm going to put telemetry dot add data, and I'm going to put status right here. Comma runtime. This is going to be my timer for how long my code will be running for. And then for here, you're going to put a plus sign. You're going to do a runtime dot to a string. And again, it placed an extra bracket where you don't need it, so take that out. And then you're going to do another telemetry dot add data. And for this one, it's going to be my servo. So I'm going to do servo, comma, servo position. Then a plus sign, and then plane launcher. Dot get position. This is going to tell you then your position of your servo as you run. Finally, we're going to see how much power is being put to our motors. So I'm going to do another telemetry dot update. And inside this, we're going to put motors. Okay, we're going to do our left. And for this, I only want to see 2 decimal places, so I'm going to put my % dot to F. Then I'm going to put a comma right there, and then I'm going to do my right. Do the same thing. I only want to see 2 decimal places afterwards, and then you're going to put on the outside left power and your right power. And then finally, you need a telemetry.update, so your telemetry is continuously updating throughout your time you're running it. And that's it! You've now got a basic teleop op mode with POV tank drive and servo control in Java for FTC. If you want to expand this, consider adding encoders, triggers for incremental movements, or gamepad 2 support. Be sure to like and subscribe for more FTC tutorials, and good luck this season!